All right, good evening, Algebra 2, Period 4. I'm excited about this unit, Unit 2C, because it is a little bit of a trip away from polynomials. I feel like we've been working with polynomials for a long time, and we're going to work with exponents today, okay? And day one, we're going to work with these things called logarithms. Okay, say that with me, logarithms. And it's not just the way that mathematicians get down and boogie. Get it? Rhythm. Anyways, logarithms are actually the opposite of exponents, and I'll talk more about that tomorrow in the day one notes. But for day 0, we really have to focus on exponents. We need to get really fluent with them. We need to be able to evaluate any kind of expression that has an exponent in it. So right at the top of the day 0 notes, there are two expressions. Okay, we say a to the 0 equals and a to the negative p equals. Now, I wrote this on the board right at the end of the quiz, and I don't think everyone saw it. So a to the 0, any base a to the 0 power is going to be 1. I can talk a little bit more about that tomorrow when we debrief the day 0 notes. I feel like it would be better for me to do that in person. But as a general rule, you can remember that anything to the 0 power is 1. So if we look at 7 to the 0 power, that's 1. If we look at 160 to the 0 power, that's going to be 1, and so on and so forth. Okay? So in those practice problems, anytime you see to the 0 power, you just write 1. Now, on the other hand, with the negative exponents, it's not as simple and as quick as a rule. So anytime you see a negative exponent, we're going to write that as 1 over a to the positive version of that exponent. So a to the negative p is equal to 1 over a to the p. And we'll do some examples of that. But in those little spots, you can write a to the 0 equals 1, and a to the negative p equals 1 over a to the p. Now there's one more, and it says a to the p over r. So we call this a rational exponent. Okay, rational exponent. And the word rational, it really means ratio, or the root of that word is ratio, and a ratio it just means a fraction. So that's where the word comes from. But so anytime you see a fraction in an exponent, you're going to have to be a little bit careful with how you handle it. So the reason we use p in the numerator is because you need to think of p as the power, and the radical is r. Now, radical is just a fancy word for that root that we see, but we worked with square root, we worked with cube root. There's also fourth roots and fifth roots, and really just n roots, or in our case, the r root of a number. Okay, so whenever we see a fraction, we're going to have to use the information that p is a power and r is the radical to help us solve the problem. So I think I should just switch the page. Let's go here. So for the example, 9 to the 1/2, that really means 9 to the first power, and it's underneath the radical. Well, the square root, we don't really write the 2, but that's what that 2 means. It means the second root, okay, or the square root. So really we're just finding the square root of 9, which is 3. All right. Another example, number 2, is 8 to the 1/3 power. And just like we saw the 2 was a square root here, now we've got 3 So we're going to write this as the cube root of 8, which we know is equal to 2. Now, number 3, oh, that's not a good 3. Hold on, let me put that in the corner. So for number 3, we are given 8, and it's raised to the 4/3 power. So there's two ways we can now write this. We can say that this is 8 raised to the 4th power underneath a cube root. This is 8 to the, oh, sorry. This is 8 to the 4/3 power. Or we can write this as the cube root of 8 raised to the 4th power. You see, it's still raised to the 4th power, and we're still taking the cube root. But because this is all very, very down to the essential, it's based on multiplication, we can do it in the different orders and get the same answer. So you need to look at this and say, wait, is it easier to take 8 and raise it to the 4th power and then take the cube root? Or is it easier to take the cube root of 8 and then raise it to the 4th power? All right. Hopefully, you are thinking option B, because we know what the cube root of 8 is. We actually did it in number 2. So if we take the cube root of 8 first, we know that from the last example, right, cube root of 8 is 2. We can say now 2 to the 4th, and that really just represents 2 times 2 times 2 times 2, which is 2 times 2 is 4, 8, 16. So this expression, oh, what did I do? Well, I'll fix it on the next slide. But the answer to that problem is 16. The answer to number 3 is 16. Oh, I can zoom. How cool. I don't know what that's going to look like for you. But. All right. So that's rational exponents. We're going to do a couple more of those. But let's practice, not with the highlighter, the pen. Let's change the color. Let's go with burgundy. So, practice number 1. It gives us 3 raised to the negative 3 power. So if we remember our definition, that's equal to 1 over 3 cubed, and 3 cubed is equal to 27. Remember that an exponent represents repeated multiplication. Okay, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So that checks out. So the reason that we have the 27 in the denominator is because we had the negative. We had to use the reciprocal of 3, 1/3, and raise that to the 3rd power. Right? The other way to look at that problem, right, 3 to the negative 3rd is 3 over 1 to the negative 3. And when we have a negative exponent, we're really taking the reciprocal. So technically, 1 is being cubed there as well. But 1 times itself however many times is 1. And like we said, the denominator is 27 there. Okay, so that is problem number 1, or practice number 1. Problem number 2, it's 6 to the 0 power. We said anything to the 0 power is going to be 1. Now for number 3, we have 25 raised to the 1/2 power. So we need to remember that, okay, the power is 1, so I don't need to adjust the number at all, and the root is 2. So we are looking for the square root of 25, which is 5. On to number 4. And you can pause this at any time. I know I'm going a little fast, but I'm trying to keep the video under like 15 minutes. So number 4 gives us 1/2 to the negative 3rd power. And we're going to use that reciprocal rule. If we find the reciprocal, we now have a positive power. 2 cubed over 1 cubed, and that's going to equal 8. Now the other way to look at this, which is kind of interesting, is if I say 1/3, sorry, it's 1/2, number 3, 1/2 to the negative 3. This is really equal to 1 to the negative 3 over 2 to the negative 3. But we remember that if we see a negative exponent in the numerator, it's going down to the denominator. And if we see a negative exponent in the denominator, it's going up, and we're going to get 2 to the 3rd over 1 to the 3rd, which we said was 8. So the thing I like about exponents is that I just showed you 3 different ways to prove why 1/2 raised to the negative 3rd power is 8. Different ways. Some of you might like that about this, some of you might not. But I think by the end of the unit you'll like it.